We already know that when we are solving, or I should say, when we are adding or subtracting fractions, that we need to have a common denominator. So in this warm-up that we have here, in order for me to subtract these two fractions, we want to rewrite each fraction so that they are both sharing the same least common denominator. So we would write this as 3 over x plus 4. Let me zoom in here so I have a little more space to work with. 3 over x plus 4 over x plus 2 times x plus 4 minus 2 times x plus 2 over that same LCD, or least common denominator. So x plus 2 times x plus 4. And when we go ahead and do some simplifying, this is just going to come up with x plus 8 over that denominator, which I'm going to expand out, or I'm going to write out now as x squared plus 6x plus 8, right? We know that. We've done that plenty of times in our previous algebra classes. What I want to do today is walk us through the process of doing the reverse of this, which is to say, take a fraction here and to decompose it or break it up into the sum of smaller fractions. And this process is known as partial fraction decomposition. And the reason it comes up in this chapter is because we're going to need to use systems of equations to fully come up with these fractions. And this is an important concept that will come up later on in calculus when we are integrating certain types of functions. We are going to need to use partial fraction decomposition to fully integrate them. So let's go ahead and try one of these problems here. So we're going to take the same fraction. So we already know what the answer is, but the whole point of this is to walk through the process of integrating, or excuse me, of decomposing this. So the very first thing that we always want to do when we have a partial fraction decomposition problem is to go ahead and factor the denominator completely. So we're going to write this as x plus 8 over x plus 2 times x plus 4. And once we've factored this denominator, we're going to create an equivalent equation. So we're going to say x plus 8 over x plus 2 times x plus 4 is equal to the sum of two fractions here. What are these two fractions? Well, one fraction is going to have x plus 2 in the denominator, and the other fraction is going to have x plus 4 in the denominator. And I can remove those parentheses. We're going to look at the fact that for every factor that we have in the denominator, we're going to need a fraction to represent that. And we don't know what these numerators are, so we're going to put these placeholders here. We're going to just call this some constant a and some constant b. Now, if later on, and we'll talk about this more, but if this denominator turns out to be a quadratic factor that can't be factorable any further, or factored any further, then we're going to need to make sure that the numerator is 1 degree less, that it's a linear factor. But let's not get too ahead of ourselves here. So the next step here, once we have this, is for us to multiply both sides by this LCD. So when I multiply my left side by this LCD here, and I'm just going to label this here as my LCD. When I multiply my left side by my LCD, then I'm left with just x plus 8. Now on the right-hand side, when I multiply this first fraction by this LCD, pay attention to what happens. I'm just going to write this for now, and then I'm going to erase it just because I don't want it to be too cluttered, but I want to make sure you see what's happening here. When I multiply this first fraction by my LCD, then I notice that my denominators are going to divide out, and what's left over is just a times x plus 4. So I'm going to go ahead and just write that there. A times x plus 4. What else do we have? Now, when I do the same thing to this denominator, multiply that by the LCD, I've got b times the other denominator, x plus 2. So from here, it's just going to be a bit of algebra. I'm going to go ahead and distribute each of those terms in the front of the factors. So we have ax plus 4a plus bx plus 2b. And then my next step is to group together the like terms. So I've got ax plus bx plus 4a plus 2b. Now, I want to bring this down because I want to make sure that we understand what we're about to do next. I notice here that I have an x term here. So let me actually just go ahead and underline this. I have an x term here. In order for these two equations to be equal, it means that this ax plus bx, the sum of those terms, has to be equal to x. So I can actually group together these terms, factor out that x, and write this as a plus b times x. And again, in order for these equations to be equal, I know that this term here must be equal to x, which means this coefficient, a plus b, must be equal to the coefficient of x here, which is 1. So what I can then do is actually rewrite this, or rewrite one part here as a plus b is equal to 1. Now similarly, let's switch colors there, I know that these remaining terms must be equal to the constant 8. So let me write that. I know that 4a plus 2b, in order for these two equations to be equal, that the sum of these two terms has to be equal to 8. So I can write that. 4a plus 2b is equal to 8. Does that look familiar to you? Yeah, this is just a basic system of equations that we now need to solve. So hopefully this is kind of driving home the point as to why this is showing up in this chapter. Now, we can just do any method of solving the system that we want, whether it's substitution or elimination. I'm just going to just multiply this top row by -4 and just write that result underneath. And if you wanted to do substitution, you totally could have. And I'm just going to add these two rows together. So that just gives me -2b is equal to +4. So b is equal to -2. If b is equal to -2, that means a, plugging this back in here, a minus 2 is equal to 1, which means a is equal to 3. So we can then say the following. We don't stop here, and once we found a and b, we want to make sure that we put those back into our PFD, or a partial fraction decomposition. If a is equal to 3, 3 over x plus 2 plus -2 over x plus 4. And since this is -2 over x plus 4, I can actually just rewrite this as -2. And that is our decomposition of our original fraction, which was x plus 8 over x squared plus 6x plus 8. This is what we box. This is our solution. And what we've done is we have decomposed this fraction as the sum, in this case difference, of these two smaller fractions.